Good afternoon. Thank you all for joining us for this talk. So this is one of three talks, all of which are looking at Sawtooth-based use cases or studies. So there was one by QMC yesterday, Quantum Materials Corporation, also looking at how they're using DAML from Digital Asset. There's another one which has been moved, I'm not sure where, because it was actually clashing, having two Sawtooth presentations at the same time, and that's somebody called Scan Trust talking about the work they're doing using Sawtooth. And so to complete the trio, what we're doing is giving you a little bit of an overview of some work that started actually a couple of years ago at the Tel Aviv Stock Exchange and how we came to be involved in this project. So if we go back in time, almost 2 years, there was a hackathon, and by the way, full disclosure, we were not involved at this point, but there was a hackathon in Israel, in Tel Aviv, run by something called The Floor, which is literally a floor within the Tel Aviv Stock Exchange that's an incubator for lots of fintechs. And Accenture, not a company that needs incubating, I should add, along with Intel, got involved supporting this, and out of this came the idea of trying to radically transform the securities lending market in Israel. So as the slide says, it was, and it still is, because this project is about to go live, a very fragmented, inefficient, and frankly opaque process. So I'm not sure how many of you understand the concept of repo markets or securities lending, but essentially what it boils down to is that if a company or an institution has stock that it essentially on its books that it's prepared to lend, there's typically somebody who wants to borrow that for a defined period of time. This is to avoid things like naked short selling and things like that. So depending on the regulatory framework, this is more or less important. And certainly in Israel, it is important to have securities lending, so you can't do naked short selling of stock. But it's done in a very sort of informal, ad hoc way at the moment. So the Tel Aviv Stock Exchange observed two things. One, it's a market opportunity. It's an opportunity for them as clearly the sort of leader of the pack, so to speak, to instigate a new market and bring something new to the market itself. But then they also saw it as an opportunity to innovate, a chance to innovate. And why is that important? Because as Yuri, their CIO, has said in interviews and so forth, they could have done this a more conventional way. They could have had a centralized system. They could have done a hub and spoke. But they felt this was a great opportunity to actually sort of use a DLT to actually push the state of that market out to the participants and give them their own view, but obviously controlled through a DLT of that market, and then tie into their own back office without the usual spaghetti junction type infrastructure. So they could see real value in doing it using blockchain. The hackathon demonstrated that this was indeed possible, and so they engaged with Accenture and Intel to build a prototype. It's called the Blockchain Securities Lending Platform, so BSL for short. So, and what is it doing? It's really enabling peer-to-peer direct borrowing and lending of stock. It's doing that through creating an order book or a number of order books. It's doing that by managing the contracts themselves. So these contracts having defined terms in terms of the length of contract, whether the contract can be essentially canceled earlier, whether it has to run to full term, various things like that. And importantly, by automating this and by creating a market, they see this as a way of generating real interest in the stock market itself and in stocks, domestic stocks within Israel, and also allowing them to do it more efficiently with reduced operational costs and so on. So greater choice, greater flexibility at a lower cost. So here are some innovative features I'd like to call out. Obviously, the last one is a little bit of self-publicity, but number one, they chose Hyperledger Sawtooth, and I'll come back to why in a minute. Number two, and this is why Intel was really interested, they wanted to actually the way Sawtooth works is it's very much, the architecture is it's highly modular, highly scalable. It's very similar in many respects, and the design principles were deliberate to provide if you like, a permissioned alternative to something like Ethereum, but follow many of the same principles. So in other words, highly distributed, and in any case, one of the things they wanted to do was to actually add a privacy model to that. So the way they've done that is through something called the private transaction families, which you can now go and see because it's actually in the Hyperledger labs. And so what that does is it allows something which in Sawtooth terms is called a transaction processor, but just think of it as the business logic to be executed within a secure enclave using the Intel software guard extension. So this is a hardware solution. So there are other alternatives, and privacy is there's this constant tension, as we all know, between privacy and being completely distributed. So is there a way of either hiding information from the wrong people, which is the notion of a trusted enclave, or is there a way of actually breaking apart the information and only distributing information to those participants that need to see it, which is more the sort of basis of things like DAML from DA, where they're actually breaking down transactions and working out who can see what. And so you've probably also come across this within the sort of Ethereum capable world, where Besu also has something similar through a project called Orion. Don't push me too hard on that because I'm the CEO, not the CTO. My CTO is there probably thinking, Duncan, you're digging a really, really big hole for yourself at this point. By the way, I didn't introduce myself. I'm terrible at these presentations. I'm Duncan, hi. And then finally, the idea of deploying and managing this as a production system is where we came in. So, Sawtooth. I'm really happy to talk about Sawtooth, although as we've evolved as a company, we've also gotten involved in other projects like Besu, which we announced this week, support for DAML on Besu, but also working with centralized ledgers and, God forbid, with databases. So, there's a big world out there, lots of use cases. Not everything could or should live on a blockchain. Sorry, heretical thought for everybody who's a member of the Hyperledger community, but such a world does exist beyond us. But anyway, within the sort of Hyperledger family, the foundation, Sawtooth, you might think of as the challenger brand, the scrappy kid brother of Fabric, which Brian has called the granddaddy. These are all terrible terms. But anyway, the point being, Fabric's been around forever. It's had a big head start. But one of the really interesting things about Sawtooth is the architecture. And it reflects its origins in many respects, in that this came out of Intel and the Intel family and the Intel philosophy of keeping things lean and mean versus the IBM philosophy of let's have a job for life and let's make sure that consultants, including our own, make a ton of money implementing this incredibly complex piece of software. So you can see coming at things from a very different point of view. So that was somewhat tongue-in-cheek, but there is an element or grain of truth to it. But anyway, scalable, highly modular, and what we really like, the clear separation between what's happening at the network layer and what's happening at the application tier. That's really important if you don't want to get completely bogged down in what's happening within the blockchain or the state, the Merkle tree itself. And then the couple that really piqued our interest were first-class support for smart contract languages. When we encountered Sawtooth, it already supported Solidity through the Burrow EVM, and it's obviously developed further and now has support for WebAssembly and with a project called Sabre, and through work we've done with digital asset support for DAML. And then finally, and if you're looking at these things as long-running, long-term, it has a pluggable consensus mechanism. Why do you think that's important? I'm going to try and make it a little bit interactive. Anybody tell me why they think pluggable consensus is a good thing or a bad thing? John? Choice is always good. I think that's very fair. So what John is saying is that depending on your use case, so for example, is it a small network? Is it a highly distributed network? Is it a very large network? All of these are factors that will drive the decision-making about what is the right consensus mechanism to use. And having a consensus mechanism that is pluggable and managed through the chain itself gives you that degree of freedom. So you can actually, not that I would necessarily recommend doing this middle of your trading day, but you can evolve or update the consensus algorithm, or maybe just put in a new version of the same PBFT or whatever it is. But my point is that you can start with dev mode, which is single machine, single node, not a DLT in sight, through to raft, which is pretty good if you're a local area, through to something like PBFT if you're wide area, but the number of nodes that you're looking at is in the 20s or 30s, but not bigger. Or you can go to POET, proof of elapsed time, which comes in two flavors, one with a hardware implementation through SGX and the other a software implementation that actually lets you roll out hundreds, if not thousands of nodes. Now, the other thing you have to bear in mind about consensus algorithms is some are forking and some are non-forking. And so in the case of the Tel Aviv Stock Exchange, they want finality. They want to know that if a transaction completes, it's done. There's not going to be excuse me, I'm really sorry, but that transaction just was in a fork that we're now reeling in, and so that doesn't work in a financial services scenario. So in that kind of situation, you're looking for a non-forking algorithm, and so PBFT currently is our preferred option. We're looking at other potential alternatives going beyond PBFT. I'll give you one example, which we're not committed to doing just yet, but VMware has open source something called SBFT, which is something that came out of their labs. There are other alternatives out there that we're also considering. So the nice thing about the pluggable consensus is I can consider these things and then I can actually use those things. So it's not just an academic exercise. And then finally, I don't need to tell you guys this, what they liked, and this is true of all the projects within the Hyperledger family or foundation, is the strong governance model that once something is contributed to Hyperledger, as you all know, it's safe. It's found a safe harbor. So it's not the case that, like MySQL, it ends up being acquired through an acquisition of Sun by Oracle, and so MariaDB comes about. Same people unhappy that now MySQL, which is still open source, the governance is questionable. So what is Sextant, and why is this being used by the Tel Aviv Stock Exchange? So I'm no good at bullet points, so this is one long sentence broken into 4 bullets. But essentially, what is it? It's software. It's a product. Why is that important? It means you can use it how you want. We're not mandating that you have to take a managed service from us or from anybody else for that matter. We're giving you software if you want software. If you want it packaged as a service, we can do that. And at the end of the day, if you want the operational model to be centralized, then you can have one copy of this that looks after every member of a consortium, or you can give every member of the consortium the same software and it will still work. So that's a very important design philosophy, to be unopinionated about how it's going to be used in production, in anger. So what does it do? It really tackles the hard problem of deploying an ongoing management of either blockchain networks or smart contracts. Why is that important? If you've ever had to run a system for a long time, you'll find entropy kicks in. Software doesn't work the way you want it to work. You want to update it. You want to maintain it over a long period of time. So in other words, if we're successful as a community, we will be building out networks that will be long-lived over years, decades, or more. Now, they'll change over time. So this is the philosopher's axe. Ultimately, is it the same axe you started with when you've changed the shaft, you've changed the head, you've changed every piece of it? Well, I'll leave you to think about that one in the bar later. But the point is, the software, the platform that you're running on needs to be maintained over time and looked after. Otherwise, it will fall into disrepair. Performance will fall off a cliff. And so that's really the area we focus on. It's the operational issues you have to address and you should think about up front. And then finally, it does all of this on Kubernetes. So Kubernetes, it's if you like, the feature project of the Cloud Native Computing Foundation, a sister foundation to Hyperledger. It's the de facto standard for container orchestration. So we've adopted it. You can find it anywhere. It's ubiquitous these days. What that means, practically speaking, is that every cloud will offer you a Kubernetes service, and you'll also be able to install it and run it yourselves if you want to run things on-premise. And you can also mix and match these things. So the way that we think of the world is, a network is a set of clusters that need to be networked. Those clusters, because we're using Kubernetes, can run wherever they need to run, some on-prem, some in the cloud, or some combination of the two. So very important to look at what's out there. Don't reinvent the wheel. And so Kubernetes was something that it was clear to us has a very long trajectory and will be supported for years. Therefore, it's something that we have adopted. So there's two flavors today, two flavors of Sextant. Sextant for Sawtooth, so that's the one that the Tel Aviv Stock Exchange is using, and then Sextant for DAML. So the interesting thing about Sextant for Sawtooth is it's not a single thing. I've talked a lot about the management platform and so forth and so on, but what's just as important if you are actually working with an open source project in production is stability. So stability of the software itself. So what we've produced is a distribution. So if you're not familiar with the term, essentially it says, as I've written there, it's taking the actual open source framework, packaging it, building it, doing security scanning on it, maintaining it, giving it long-term support. LTS is, I hope, a phrase you're familiar with. Long-term support is something that every enterprise wants to know, that they're not going to be given something that 6 months from now they can't use, or they can, but only at their own risk. And this distribution is not a fork of Sawtooth, other than where we've actually made fixes, which we're in the process of contributing upstream, or where we've backported features to 1.1.x, which is what we're working on, which are only available in 1.2, and the community has not done that backport. So there's a few minor changes that we make, but they're all in the interest of making this a stable, long-term platform. And we'll upgrade when we think that 1.2.x is stable enough for us to also provide long-term support for it. And the good news, you don't actually have to license Sextant in order to access the distribution. So that's available freely on Docker Hub, and we think that's important, that we're building something that the community can use. So there are companies here that are using Sawtooth. We're saying, please use this, it's stable, you're welcome to it. You don't actually have to use the management platform itself. We'd like you to, but there's no obligation, there's no close coupling between the two. So this is as technical as I'm going to get. This is a way of visualizing the actual stack itself. So you've got the substrate, you've got your cloud or on-premises substrate, you have Kubernetes, so we will not support anything other than Kubernetes. It's too risky for you as a customer or you as a consumer. And then on top of that, there's the Sawtooth distribution. And then the key thing that differentiates my Sawtooth network from yours, from the next one, is the custom TPs themselves. This is essentially the business logic. So it's the equivalent of the chain code in Fabric and so on and so forth. So the point here is that we take responsibility of managing that whole stack for you, and that's really the essence of what Sextant is about. So what is production readiness? Since we're making the claim that we are working with the Tel Aviv Stock Exchange on production readiness. And that was something I said we'd talk about in the talk. Well, it's all the non-functional requirements that go with taking something that's a concept and making it something that is usable in the long term and is something that is supportable in the long term. So number one, governance. So governance has been a hot topic here, and it's not something we can solve ourselves on our own, but governance is one of those things that you actually have to talk to, in this case, the Tel Aviv Stock Exchange about, and say, what should the governance model be? Is it fully trusted, partially trusted, trustless? All of these decisions will impact the way in which you actually roll out and configure the environment, and who's doing that rollout, who's doing that configuring. So that's an important part of production readiness. Operations. So operations, this is all, when I say operations, I mean all of the fundamental operations, the ops in DevOps, essentially, all of the processes that you have to put in place to maintain software over the long term. So give you a good example, a node dies, or the server supporting that node dies. great, it's Kubernetes, I can spin up another node. Yes, I know that, but there is a process you have to go through to actually add that new node to the network, either retain the identity of the old node or create a new identity for the new node. And when I say node, this will be a node in a Kubernetes cluster, okay? Again, that's a good example of operations. Backup and restore sounds incredibly boring. You know, it's super important, okay? So this is a way of actually ensuring that you can quickly spin up nodes, new nodes, rather than actually having to rebuild the entire state of the world from scratch. It's a permission network, so within reason, this is a permissible activity or operation. Security, I mean, I don't really need to dwell on that, but here I'm talking not just about security in terms of, you know, the actual, we talk about that a lot in terms of the DLT itself, but this is how do you actually manage things like the keys themselves. There's an awful lot around that which also bleeds into operations as well, where you're looking at what is the security model, how am I going to make sure that the Kubernetes environment is secure, the containers are the right containers, et cetera, et cetera. And then support. Support is you don't just deploy and then walk away, fire and forget. It's putting in place all of the processes. Again, this is nothing to do with blockchain networks or DLTs. This is just being sensible about how you plan to support not just a platform, but a new market or trading platform. So not just the infrastructure, but the actual business application itself. And then user acceptance testing. These terms, by the way, have been around for as long as I've been around. So the whole point about this is applying what we know to this domain, not trying to invent new fancy terms for what we're doing, but just say, look, the same discipline has to be gone through. I'm heading for the most boring talk of the conference, I know, but I apologize. But you know, these are the things you have to think about. So anyway, this was the original announcement. This was May 2018. Okay, so we think that with the work we're doing, the preparation we're doing, we're now well on the way to actually launching this. So it will have taken, by the time it's launched, a fairly typical 2-year time frame to go from concept to POC to production. It's important that we understand these timescales, and that's quite an aggressive timescale. It might sound incredibly slow if you're a startup, but if you're an enterprise, this is normal. This is what you have to be used to and accept. You can try and change the way an organization works and thinks, but it's pretty much an uphill battle to do that. There are processes that they have to go through, regardless of the offering. And of course, if you're creating a new financial market, in this case, securities lending, you can't half lend securities or lose securities. Well, you can, but it's pretty bad from a reputational point of view. So the point is not to do that. And then finally, we were able at FinTech Week in Israel, in Tel Aviv, 3 weeks ago, February the 10th, to announce our partnership with the Tel Aviv Stock Exchange. And they're now really excited about the potential. And I talked earlier on about how they saw it as a market opportunity and an opportunity to innovate and be seen to be innovating. This is actually really important because last year in August, they actually floated TASE on TASE. They actually floated the Tel Aviv Stock Exchange on the Tel Aviv Stock Exchange. So it went from being a utility owned by essentially the members, the banks by and large, but other institutions, which was not for profit, to being now a initially privately held and now publicly held stock. So innovation, demonstrating their forward thinking now becomes super important. And not just the Tel Aviv Stock Exchange, I would say, but the Israel Securities Authority and the Israeli Innovation Authority. These organizations are taking DLT very seriously and putting out requests for proposals, some domestic, like the one from the Israel Innovation Authority, some global or international, like the one from the Israeli Securities Authority, where they're saying, tell us what you think. How should we be using this new technology? What use cases should we be addressing? So very forward thinking about how to actually embrace this, which I think is important. If you were in Don Tapscott's keynote, or rather watching him deliver it, which I think he did a fantastic job, especially given he was ill, and it's very hard to talk to a Zoom meeting. What he was saying there is that, one of the myths that he was busy debunking is the idea that somehow blockchain technology and adoption of blockchain has stalled. Not true. There are some people that are dragging their feet. But when you see people like, and we've met with the Israeli Securities Authority saying, yes, we love the idea, but we want to know how to best use it, then that's when then I get excited that here is, a regulatory authority. And I was in a room with a lawyer, by the way, so they were taking this meeting very seriously, minuting it and so on. But the point was they were keen to hear about new ideas, new ways of doing things. And Messina, who's here in the audience representing the Global Business Blockchain Council, her organization, they're doing this at scale, talking to many of the different regulatory authorities around the world, as well as working with companies like ourselves and other companies. And the idea there is to sort of, again, educate people. It's to show them what is possible, talk about what's happening somewhere else so that you get this idea of, ideas are interesting because, when somebody has an idea, it's easier for somebody else to have that idea. It's even easier for them to have it if you actually share the idea with them. But there is this very interesting phenomenon about scientific discovery, which is slightly off topic, I realize, but where simultaneously you will get the same discovery occurring in multiple parts of the world. Why? Because essentially there is a sort of upswell of thinking and concepts, and those concepts kind of gel around certain key ideas. So The Structure of Scientific Revolutions is the book I'm referring to. But anyway, my point is, it's really interesting to have that people like the GBBC taking that message on the road, actually getting people to talk, whether it's companies to regulatory authorities or vice versa. So, time for a demonstration. And a really bad joke. I have no idea how much time I have. I think I have time to give a quick demo. I apologize in advance. This is to manage expectations. I can't demonstrate the blockchain securities lending platform. I'm not allowed to do that. You will appreciate that that's something that is owned by the Tel Aviv Stock Exchange. But I will try and give you just a little bit of a demo of some of the stuff that we can do ourselves with Sextant and how that's. Okay, good. So that's my daughter's message. So sorry. I'm also chief travel officer for my family. So I earn the air miles. They burn the air miles. So probably not the sort of thing you should say these days, but anyway. So if you recall, we've actually got, as I mentioned, we've got two flavors of Sextant. They look remarkably similar. Spot the difference. Well, the point about them is they are designed to be the same because you want the same user experience, but where one is focusing on, at this point in time, just giving you the tools to work with Sawtooth, the other is giving you the tools to work with not just Sawtooth, but also with DAML from Digital Asset, so a smart contract language. But let me stick with Sextant for Sawtooth. So I'm logging in. That's presumably a concept most of you understand, I hope. So it's super simple. And by the way, there's an API, a very rich API that stands behind this. But the point is, what we want you to do is focus on what's really important. And in this case, it's two things. It's clusters, Kubernetes clusters, and it's deployments. What are you running on those clusters? So this is a cookery show. So here is a cluster that I deployed over the weekend. And if I look at it, yep. Bear with me one second. What am I showing here? This is a sort of canonical view of a cluster a la Kubernetes. So not terribly interesting, but what it tells you is that there are 4 machines in this cluster. They happen to be running on US East 2. I can do really useful but not terribly exciting activities, like I can add a new cluster. I won't do that now, but essentially we provide you with the help you need to import the details. So there's only 3 key things you need, 4 if you include the name of the cluster as it's understood by Sextant, but you've got to give it the API server, the access token, and the certificate authority. These are the things that you are giving us to allow us to then manipulate that cluster. But as I said to you before, I think deployments are more interesting, so let's look at deployments. So we have one deployment, and again, I'll just let it catch up. So what are we doing here? We're running an instance of the Sawtooth network. Now, if I want to change that, and by the way, we only allow one deployment per cluster for obvious reasons, because the idea is that, you're rolling out you're rolling out your network on dedicated resources, in this case Kubernetes clusters. So whilst technically you could commingle them, the great thing about virtualization and containerization is that you can right size the clusters rather than try and do the other thing, which is work out the combination of things to run multiple networks. It's the beauty of the world as it is today compared to when I was starting out, where we had servers, we had tin, big tin, little tin, and that was it. And eventually people figured out ways of slicing that tin, and eventually virtualization came along. But anyway, let's see what we can do with this deployment. Well, as I said, I can only have one one deployment running at any given time. But what I can do, and this is again the beauty of Kubernetes as the underlying technology, is I can redeploy that network. I can make a change, I can make an upgrade. And if I do that, so for example, and I'm not going to suggest I do something radical like change the consensus, but if I want to change one of the options, or I want to add, I want to add something, then I can hit redeploy. And what Kubernetes does is it does a diff between the world as it is to now, the state it's in, and the state that you want it to be in. And it works out what is the diff, what is the change I have to make. Oh, so you've actually introduced a new version of the validator, so I need to roll that out, or a new version of a transaction processor. Excuse me. All right, I'm doing a lot of talking. Let me actually break the rule I said and actually go to this guy and add a cluster. So, Sextant. So Sextant, pretty much the same thing, except this has no clusters. So let me add a cluster. So now I've actually got to use these instructions. I've also got to check that I'm actually talking to the right cluster. So, which I wasn't. So this is sort of the behind-the-scenes stuff that I'm doing because I know what I'm doing. But there are also ways of just setting that through commands. So I'm just being lazy and using Visual Studio for this. Go back to here, and if I grow this window, hopefully it will be visible what I'm doing. So the first thing I've got to do, and I'm following the instructions, I do actually follow instructions sometimes. I'm creating a service account because if I go back to here, not here, sorry, here, that's the first thing it's telling me to do. And I've downloaded these instructions before. Then I'm going to get the credentials. And then I'm going to grab those credentials. So I'll actually start with this guy. Oops, start with this guy. I could just type this in, but it's easier to cut and paste. Drop that in, go back to here, grab this, grab the token. And again, I mean, a lot of this we're exposing, but again, can be done through something called CI/CD, continuous integration, continuous deployment, where all of this information is being gathered automatically and fed in to us through the API. But this is sort of showing you how it's done with a little bit of manual effort on my part. This is about as hard as it gets, by the way. And I was going to show you a video of paint drying while I did this, which is really fascinating. If you've ever watched paint dry, you can actually speed it up. You have watched paint dry. This is just running. Kevin, maybe you can answer this. It's just, Kubernetes. Yeah, I mean, it might have been easy. The best way of thinking about this is I'm now importing enough details to use that cluster and address it from Sextant itself. So now Sextant has visibility of that. Then the thing it can do is it can deploy to it. Before it couldn't because there were no target clusters. I see, sorry. Correct. Yes. In fact, I'm going to do demo on Sorties as it happens. But yeah, so here's the key thing. First version we had actually had a bit of extra stuff to say, go roll out, build the cluster for us. We then discovered in the meantime, not discovered, it became clear that there were tools dedicated to doing that. So EKS CTL is a tool that Weaveworks came out with, which has now been adopted as standard for EKS. So we just provide instructions for how to use that. And they are instructions that, on the one hand, you could say, well, do you need to know about a bunch of stuff? It looks quite intimidating, but in actual fact, we again give you the breadcrumbs that you need. So, it's I would say there's different types of user. So I'm sort of admin, so I have all the power to do all of this. We can actually restrict it so you're just giving access to either a single cluster for people to work with if they're testing things, or even you can narrow it down even further. So there's a standard role-based access so that you can create different accounts. I tend to, and probably arguably should make a distinction between what I'm doing, which is everything, and what you might give a member of your team, let's say, if you want them to just focus on quick round trip, deploy, redeploy, update the TP, that kind of thing. Where all they're really doing is rebuilding one image and retesting that. So anyway, so back to here. So because this is with the Sextant for Sawtooth, you have basically you're only deploying Sawtooth. Here we're giving you the choice of DAML on Sawtooth, DAML on Aurora, or DAML on QLDB, and we will shortly have available generally DAML on Besu. So we announced that seems like ages ago, but it was only yesterday. And the idea is to again provide commercial support for that through the same UI. And everything I'm doing, as I said, in the UI can be done programmatically as well. So let's stick with DAML and Sawtooth. So it's by and large the same dialogue as it would be for the Sextant for Sawtooth, except for we've constrained the number of choices, because if you're working with DAML, there is no real need to add in a whole bunch of other Sawtooth-specific transaction processes because they're not relevant. So we've cut it down to the minimum you need. You can still add custom TPs. So we have a customer that wants to mix and match both what they're doing with DAML, smart contract layer, and what they're doing at the sort of native Sawtooth layer. You can think of that as the kind of, well, exactly that. You're then creating transaction processes that are doing specific business functions for you. So we still support that option. Something which is worth highlighting is if you're part of a larger network, you can specify essentially the what they call the external seeds, which is, or what we call the external seeds, which is really, give me the breadcrumbs I need to connect my network to an existing Sawtooth network in this case, which is important once you get beyond just working in a development environment. You now want to roll this out and test it across multiple clusters, across multiple regions, multiple clouds, you name it. So all of that, again, is part and parcel of what Sextant is providing. So back to that notion of handling all the operational stuff for you, this is a good example of that. So I'm just going to go right ahead and deploy DAML on Sawtooth. And it says it's successful. Nothing is instantaneous. We should know that if we're in DLT, right? But again, with things like Kubernetes, what we've done is we've issued the deployment command, make it so. It's taken our information, converted that into a manifest, which is then provided to Kubernetes using standard Kubernetes tools. And now it's up to Kubernetes to go build this thing. So, which it will probably do quite quickly. Yeah, or not. Let me go here and see what's going on. So this is now behind the scenes as well. kubectl. Get all namespace. So this is the stuff that you don't really want to type because you'll get it wrong, or I will anyway. Look. Ah, okay. All right. Who spotted the deliberate mistake there? Yeah. It's always a good idea to make sure that I haven't been faffing around. Excellent. So what this is showing me, and I'll go back and see if I can now refresh it here. Great. Right. So actually, this is quite a good test. I went and looked at the world from the Kubernetes kubectl, which is a command line, to see whether things were running. The state of Sextant caught up with that and is showing the same thing. So we are both seeing the same thing. What's interesting looking at this very low level, relatively low level, is you can see here that what we've defined to be the actual daemon set, the actual containers that make up that daemon set. So in Sawtooth, there's the notion of a validator. So every node has a validator, but every node also has a set of TPs hanging off that validator as well as a REST API. And so all of that ends up being a daemon set. Think of that as a collection that is going to be deployed as a single entity. So either it all deploys successfully or it doesn't. And so you've got here 10 out of 10. I like that, 10 out of 10. I was always happy as a kid when I got 10 out of 10. But the point here is that means 10 of the containers that were meant to come up came up and were successfully deployed. So, all right. I should probably stop there. I think I've slightly overrun. If I just quickly go back to the slides one final time. And those of you who thought I was going to play it from the start again can breathe a sigh of relief. So Sextant for DAML, which I happen to show you, is really just an extension of what we've done to date with Sawtooth, only now we're providing the management of DAML artifacts as well as Sawtooth itself. So it's more of the same, and more of the same is good. So taking a basic platform, extending it in the directions it needs to go, support DAML. In this case, this is DAML on Sorties, but as we alluded to, there was DAML for QLDB as well, the quantum ledger database. Nothing to do with quantum computing. It's a cool name for something that has been around for decades, I think, but essentially that's a centralized ledger. So if your use case requires a centralized ledger, perish the thought at the Hyperledger Global Forum, but there are use cases, as I said at the beginning, where that is entirely sufficient. Then we have an integration of DAML that runs on QLDB. And we're getting a lot of interest in that because there are some enterprise use cases where you don't need the full power of fully decentralized ledger. So that's it. I'm supposed to say any questions. I think I've droned on a bit longer than intended, but I'm happy to take any questions or just talk to you guys. I'm surprised I haven't been kicked off by the next presenter, but maybe I'm eating into your tea break, I'm not sure. Anyway, that's it. I'll stop there, stop rambling, and thank you very much for your time. And to those of you that stayed, that's all of you, a big thank you.